Alright, I think I had... I think I had some sort of technical difficulty. I'm here in Japan, and despite having high-speed internet, they do not have Ethernet in your house. So it is always annoying to get kicked out of Wi-Fi whenever it's happening. But now I'm connected, and hopefully now it's working. My bitrate is back up, though I've just lost all the viewers. My 2 viewers, oh no. Whatever will I do without the 2 viewers that I had? Let's go back here and go back. Alright, I'm back. I just had to figure out what was going on with my internet connection. Unfortunately, I don't have in-house Ethernet or anything like that, and I am upstairs, and our router is downstairs, so I am streaming over Wi-Fi, and that has its whole host of problems. So I can have the most decked-out computer in the world handling all sorts of streaming, and then the internet cuts out and it's got no point. But oh well, I'm back now. So what we gotta do first is we need to take this sort of string that's got text associated with it and just turn it into some sort of number so that it knows what's going on. Unfortunately, like 1,000 different cocktails isn't enough to train some sort of full text recognition model. So this is not going to be, if we just train it off of what we have right now for the text input, it's probably not going to know just the vast majority of words. It's going to know some weird words, like whatever Minnehaha is, and it's going to know words like Waikiki and beachcomber, but it might not know, the vast majority of words. So from a proof of concept standpoint for today, or for right now, it'll be fine to do this, but in principle, with only 990 rows of data, you're not going to train the next Google Translate. You're not going to train the next text processing model. But you can at least train it for cocktails based off this information. So for now, we'll be naive. We'll just say, sure, it's probably enough. And we're going to create our own text vectorization thing off of it. What it's going to do is it's just going to turn each piece of text into a bunch of numbers based off of what word it is. In kind of a dictionary perspective. And since we're dealing with English, words are things that are separated by spaces. And this data is very clean. No commas, no punctuation, no nothing. So it's very easy to do, and we can just send it all to lowercase and be on our way. So we're going to create a text vectorization layer. And so never feel ashamed whenever you're programming to look things up. I've been working at a large company leading a machine learning team, and now I'm going to another, well, not another large company, but a new company to do machine learning stuff over there, and I Google dozens of things every single day. So I'm going to look up what are the arguments for Keras text vectorization. Because I don't remember every single argument for every single function I've ever used. And also, if anything is ever not clear from the screen or from the chat or from the stream, let me know in the chat, and absolutely I'll zoom in on it. And if there's anything you ever want me to stop and talk about, please feel free. This is my very first stream, so I'm just kind of playing it by ear. So, feel free to chat, follow if you want to follow, and just let me know what you think would be a good idea to do. Because honestly, your input is probably better than what I can come up with. Whatever. Oh well. We'll say there's 1,000 or 10,000 different words. Output sequence length will just be will just be 5 words at most. And add to max tokens will be true. Download. In the meantime, we'll just copy some more code. So 100. Alright, I'm back now. I just was waiting for things to download, and that doesn't make interesting content. So we're going to go ahead and take a 300 dimension pre-trained embedding, because 1,000 cocktails is not enough to train a way of reading text from scratch. So that's what we're going to do. And this is a very large pre-trained thing supplied by, I believe, Stanford. Yeah, Stanford actually, in collaboration with Google, I think. And this is just going to make our life much easier. We don't have to reinvent the wheel. We don't have to make natural language process happening from scratch just to suggest some cocktails. So we're using 300 dimensional one. We're going to have some max tokens of 10,000. And then what we're going to do is we're going to need to read in those embeddings manually. So we're going to do this, copy paste code, and let's just put it here. So the path to the glove file is just going to be this string. H4PZ, thanks for the follow. Yep, I'm working on a cocktail creating AI right now. It's coming along nicely just to start. Its project's just starting right now. But yeah, if you have any questions or comments or anything that you want to see or explained, feel free to let me know in the chat. Thank you again for following. Oh yeah, thanks. I turned on this theme a long time ago. This like kind of dark theme, and then I completely forgot about how to change it. So I've stuck with it for months and months now. There are a couple of things I would change with it, but it's good enough. But yeah, unfortunately, all of the websites I'm using aren't dark theme as well, so when I Google things, it might blind you. There we go. So right now, the goal is to be able to take in just any sort of name that somebody gives and come up with some sort of cocktail to present to them as a suggestion. So our input is going to be a string, and then it's going to do its machine learning magic to then turn that into something else. A lot of this stuff has already been done in the past, at least for like natural language processing, so it's not going to be a huge training process. Right now we are taking some already existing embeddings, which are basically meanings about text, and turning it into real math, like vectors of what it is. So luckily, there's already example code of exactly how this works. And we can just mostly copy paste from this. Now, in their example, they are fitting a vocabulary already with 20,000 different tokens. We are not going to have nearly that many different tokens because we're just looking for different names of different things. But we can add more strings as well based off of some sort of dictionary as well if we want to support more words. So for now, as a proof of concept, we'll just stick with the words that are in there, which they use right here. Yeah, I just started learning natural language processing not long ago. I really recommend like deeplearning.ai, their courses on it. They're really good courses to learn a lot about like machine learning. My goal this year, just kind of as a New Year's resolution, is to try to do a different project each month, just streaming the development process and then making some videos out of the projects. This one is a cocktail recommendation, or cocktail creation, actually, off of natural language, and then another one that I'll be kind of doing alongside it or off and on with it is a Pokemon Nuzlocke player AI. Because I am bad at video games. But for now, I'm working on the cocktail one. So let's reorganize the code a little bit. please. Oh. Converted 985 words. 90 misses. So this is a little bit of an issue. Unfortunately, our pre-trained AI, or our pre-trained embeddings that we're using are not containing all the different words and vocabulary that we might want in the names. There's only about 90 misses, so maybe it's not the biggest issue. But it could still present some problems down the line. But for now, we'll be okay. It's got 985 of the words. Unfortunately, cocktail is probably most of them. But I think we'll be okay. So now we've got our embedding matrix. Yeah, exactly. Like 90 misses, it's like it could be a little bit concerning, but it's probably just these like kind of terms. Like I have never heard of Minnehaha or however it's pronounced, or Wallach or Waikiki. Really, the idea is that it can take in just kind of general text and come up with a cocktail. So if it doesn't know these words, it's probably okay. Yeah, like I mean, honestly, this is the first week of the year, so who knows if I'm gonna be able to stick to it. But that's the goal, anyways. Is different project each year. This is actually the very first stream of the year, so he's going for it. But and I've done a decent amount of natural language processing in like a kind of professional sense so far. I work as a machine learning engineer here in Tokyo, or I live just outside of Tokyo. Yeah, so like despite it being my first stream, I did spend like 2 weeks getting everything set up for it, because I'm kind of a neat freak in that perspective. I want everything to be polished and looking nice. I probably don't have the confidence or the streaming skills to back that up yet, but at least it looks somewhat polished from that. I'm sure some things aren't really working properly yet, but oh well. Okay, so so far, just to explain a little bit, basically what we've done is we've created some model that can take in a string, is what it's feeding as some input, just one string. It's going to vectorize it, which means it's just going to split it into some numbers for each token that's going on. And then it's going to turn it into these kind of vectors of information. And Stanford has pre-trained these embedding matrices that we can use. That will kind of turn just a single token number of what a word is into something that's kind of like a mathematical meaning of the word, where similar words will have similar vectors and opposite words should have far apart vectors. So this is just so that we don't have to reinvent the wheel to train a cocktail creation. We can just use somebody else's pre-trained things, and as long as 90 misses, the miss rate isn't that high, we'll probably be okay. So now that we've got an embedding, the idea is we'll probably want to read the input string. And to do that with machine learning, typically you do like an LSTM, which is going to basically take in each vector, so each word, one at a time, and do some sort of neural network crunching on the numbers, and output just one value for the whole thing. So we're going to create an LSTM. In this case, maybe, I don't know, 128. The sizes and shapes of neural networks surprisingly are more of an art than a science, and people just like powers of 2, so we choose powers of 2. And 128, sure, sounds good. If it's not good enough, we'll bump it up. If it's still okay, we can bump it down if it takes a long time to run. And all we want out of this is to kind of just compress down the information about the input string into something kind of meaningful for a neural network. So we can actually just leave it as just an LSTM of 128 layers, and it's going to read this embedding that we've done. And so this output will be a like 128 dimensional array, or an array of size 128, sorry, for each example. And the hope is to then build a neural network that then can generate some ingredients for it, or at least based off of this information, pick which ingredient should be in which measurement. So for now, I think as a simple first concept, rather than having it output text in the form of instructions, which would just be like another sequence of like this is what you should do, to instead just say this should be your ingredient 1, this should be your measurement 1, this should be your ingredient 2, this should be your measurement 2. I think for a proof of concept, just to have one thing up and running and we can say that it's working, that's a lot more attainable than full instructions. But of course, it wouldn't be a cocktail creator if it couldn't tell you how to do it. So that'll be the kind of next thing after that's working. So we've got kind of the first half of the model. This is going to take in some stuff and kind of encode it into some 128 number thing. So it's going to take in a full string and do that. In fact, when people talk about encoders, this is what they're talking about. It's taking in your just whatever input format, however it looks, strings, etc., and it's turning into something that, based off of some calculations and some numbers, is a representation of what you gave it. So if we take in the inputs and that final layer, we can then see what it looks like. Ooh, I think it's just shape instead of input shape. Has 3, 2, 3. Okay. Ooh, I might have an off by. Yep, I added an extra 2 when I had already added the 2 right here. There we go. So what it's doing is it's taking in a string and doing all this like text vectorization. So it's going to chop up a string into just numbers, and then putting it through those pre-trained embeddings, and then training an LSTM on the output. So this is just kind of the first half of what a real model would be to solve this problem. And now we can actually kind of work on what the second half would be, which is more of the output, where then we'll build on top of this model to then go to 12 output columns, one for measurement and one for ingredient. So let's take a look at that again. So if we look at something like ingredient 1, it's just a bunch of categories of alcohol or kinds of alcohol. So while these are strings, it probably will be okay to just treat them as like a categorical variable, because most of the time, most cocktails will use the same set of ingredients with just like 1 or 2 swaps. They don't use a lot of like very rare ingredients, and we probably don't actually want a model that'll just come up with brand new ingredients, because if it's going to recommend a cocktail, we probably want to be able to make it. If it comes up with some other ingredient that would be good to use in it, then maybe that's interesting, but it doesn't mean it's useful. So we'll just treat this as some sort of categorical variable where it will be predicting for ingredient 1 one of these different categories, which if we check to see how many there are 238 different ingredients. So that's real simple. and then so let's do that kind of data cleaning. So what we can do is we can say something like ingredients is equal to pd.concat. We're going to concatenate all of these different ingredient columns into one, get all the unique ones, and that's going to be all of our different possible ingredients. 1, 2, 3, 4, 5, 6. So we've got 688 different ingredients. And then as for measurement, this is really something that's just numeric, but has ounce attached to it sometimes. So we probably just want to turn this into a number. Would be ideal, not some sort of categorical variable. Now, then again, it could actually make sense to do it as a category if you want to limit what the model can recommend. It's not typically the case where it's, oh, this way is better and this way is, the way you should do it. It really depends on what you want, because maybe you don't want a model that can come up with very unique measurements. Maybe you want a model that just picks half an ounce, 1 ounce, or 2 ounces, or 1.5 ounces or something, and that's it. Like, that's completely reasonable from a user perspective. And in a lot of courses or study of AI, you don't really think about that. You just kind of think about things in terms of what's better or not. But this is really a case where who cares what's technically better or what's technically reasonable. We care about making something that's usable and can get things done quicker. So we might also just do categorical. And I think actually that makes sense. It's certainly easier than trying to clean the data or whatever. So why not? Oh, hey, Marius Mopar. I hope I pronounced that correctly. Thank you for following. Sorry if the stream's a bit scuffed. This is my very first stream on Twitch. I am making an AI that can create brand new cocktails if you just give it some string to do. Yeah, absolutely. So I, just for a quick, rundown, so it's going to be machine learning based. I'm a machine learning scientist. I work for a big company in Japan. I'm here in Tokyo right now, actually, or right outside of Tokyo. It's like 15-minute train ride. And so I am a real big fan of just kind of doing machine learning, and my New Year's resolution for this year is to do a different machine learning project every month. So this time it's a cocktail creator, and another project that I know I want to do probably starting this next month, but maybe I'll do it on Tuesdays. I'm not really sure yet of schedule. Is going to be like a Pokemon Nuzlocke player, so completely different fields of machine learning. So far I have got the first part of the model, which is going to take in a string and turn it into just some 128 number representation of the string, just using some pre-trained stuff that I downloaded from the internet. And then the second half, that's going to be where the new cocktail specific part comes in, which is where it's going to take this 128 number thing and turn it into what 6 ingredients should you use with their 6 measurements. But yeah, so I'm a big fan of like generating and those types of things. Like a lot of my free time at the end of this last year was machine translation between Japanese to English, because despite working in Japan and working for a Japanese company and living here for 2 years, I do not speak Japanese. So I thought it'd be fun to try to create a machine translator. Oh, right. That's not how that works. To get a categorical takes in the actual data. Yeah, I knew I was missing one step. But yeah, so if you have any ideas of things to do or things that you want to ask about, I'm a working machine learning scientist here in Japan, and I can definitely point you in the right way or answer any questions or things like that you have. My idea of the stream is just to kind of have it be a relatively chill thing where it's just, rather than developing things silently on my own and not stream it, just develop things while streaming it and see who pops by and talk to whoever. So definitely Python, unless you're talking about actual natural language, then English. But like for machine learning projects, even for like deployment and like at scale things, it's basically always Python, because you don't really see much like use for anything else when Python already has so much support and so many tutorials everywhere, that all of the machine learning parts themselves, the libraries, they're written in C in the backend, but you use them using Python. So like a lot of people on the internet post things like, oh, you know, you can't use Python because it'll be slow, but it's from a practical perspective, it's kind of nonsense. It really doesn't matter, and just use whatever's easiest to learn and teach other people. Yeah. And then for like actual production stuff, like when it's deploying it, it's like doing some sort of like Docker compose, whatever. But yeah, so I also only have like a bachelor's degree. My degree is in applied mathematics, so I'm not a computer science person, but it's close enough to computer science. It's a good mix. And so like I mostly did like just self-taught AI, and so that means I was just doing like Coursera courses. If you haven't done Coursera before, it's a really good platform, especially like deeplearning.ai's courses. They'll take you from like not knowing anything. Oh hey, welcome back. Yeah, we're just getting further along in this and talking about libraries and tools for machine learning. But I mostly use TensorFlow and Keras. It's not like hard to use. There's tons of tutorials, and that's kind of the more important thing when it comes to like actual like working in a company, is can you get it working fast and then move on. It's not, does it work 10 seconds faster than another one. There we go. You could technically do this faster in a loop, but I am not about that life. I'm about the, if it's only 6, just copy paste. And now if we look at DF, we can see that ingredient 1 has just been swapped out with a number. So this isn't necessarily best practice for measurements as well, because measurements are a numeric thing, and so maybe they should be treated as a numeric field. But honestly, you know, for different practices and different things, you know, it might be fine to do this. Website. Oh yeah, so you can absolutely web scrape, and in fact, you'll probably get a lot more than the cocktails I have. But what I recommend, especially for fun projects like this, where, you know, the performance doesn't matter. At the end of the day, you'll have something that creates cocktails, and then you'll drink them on stream, and it'll be content, right? Like, you know, this is not a mission critical application. So if that's the case, you can just find simple data sets on websites like Kaggle. And that's what I did in this case, is I found one that had about 1,000 different cocktails in it, which was this one, this like Mr. Boston cocktail data set. You create an account, it's completely free, you download it, and this is all completely perfectly structured. They claimed the usability was like a 5.3 or whatever, but this was honestly really easy to use, and we're almost there actually. Like, we can get a first draft model working in probably the next 30 minutes. At least training in the next 30 minutes. I'm going a little bit slower than I normally would, just because, you know, I'm also chatting and I've had 2 drinks while I was working on this. But, you know, it is what it is. It's just a fun project. And now let's fit on. But yeah, so I would always recommend checking out Kaggle to see what they've got there. Oh, oops. I need to stop that. Oh, and also, I don't know if I've mentioned it with you guys in chat right now, but all the code for this stuff I'm pushing to GitHub, so anybody can, you know, play around with it, see how it works. And right now this is just a Jupyter notebook to play around with it and get something working, and then I'll restructure it into a Python script and have it work on anything else. Yeah, okay, my GitHub handle is for this new kind of New Year's resolution thing is Volander AI. It's the same as my Twitch. But I have another separate personal GitHub that I use for other things. So anything from this stream going forward will be on Volander AI, which I think I also have a link in the about page of my Twitch, like called links, and that has a link to the GitHub as well. And I'll be uploading edited, shortened down things, both for tutorials and like a whole project summary to YouTube. Oh, thanks for the follow. Now, officially, my Volander AI GitHub account has more followers than my actual professional one. But I use my actual professional one for not much serious stuff either, so it's probably not a big deal. Okay, so now we've got every measurement and every ingredient as an integer. which is the kind of language of, machine learning models. You could technically train it directly like this, but we're going to go ahead and split each measurement and ingredient into many, many more columns for all the different possibilities. Yeah. Oh yeah, thanks for the offer. I'm not yet sure if I'm gonna say, my real full name. It's probably not hard to find, because I've already said that my first name is Trevor. And I work in Japan as a machine learning scientist, and you could probably find that just from brief Google searches on GitHub. But yeah, thank you for the offer. But yeah, and the strong thing about Keras and TensorFlow is that so many of these normally kind of gross things to do, like turn one column into 600 different columns with like a 1 or a 0, is just handled for you by some built-in function. So it's very easy for us to just expand all these out into new things. So what we're going to do is we're going to kind of create a bunch of new kind of boxes of new data frames out of each of these columns, and then just kind of concatenate them together. Yeah, so language generation is definitely difficult, especially if you're just throwing it into things yourself. It's very easy to have something that runs, but it's just awful. I learned a lot by doing machine translation from Japanese to English, and actually a really good resource is those Coursera courses, deeplearning.ai. They go into a lot of detail. If you have any background in calculus or anything, then you can really get a lot more out of it. But even without any background, you can still learn a lot from it. And other than one general intro to AI course that was kind of whatever from my university, I'm entirely self-taught for machine learning, and I'm working in machine learning in industry. So I BS'd my way through enough, and I know enough machine learning to get by. And honestly, more than anything else, it is very possible to learn machine learning completely by yourself online. But all right, so what we're gonna do is we are gonna have a bunch of pieces, and we're gonna append each piece. So pieces.append is gonna be just the data frame with the name. Yeah. And do we need anything else? I think for now we'll leave out the category, because it doesn't really seem to be that useful. I mean, maybe if you gave a name and then you said you wanted it to be a gin cocktail, it would use gin. But for now, I think it's more interesting to just give it a name and see what it comes up with. If you want it to actually be useful, I guess you would add some more fine-tuning things. So we're just going to pull the name. And then what we're going to do is we're going to append each of these kind of two categorical things. So one example is if we have this, if we do .to categorical on ingredient, this gives us a 990, so as many rows as there are, by 688 column thing, because there's 688 different ingredients. We want to turn this into a data frame where it's got all of that data in data information in it. And as for the columns, it's got all of the ingredient labels. Which I believe is like ._classes. Ah, classes underscore. I was so close. I had the idea of doing this stream, since it's a cocktail creation script, of doing this stream where every time I had to Google search something, I took a shot. But I'm realizing now that would have been a major mistake. So maybe save it for not my first stream. But I've been getting better about it. I've been getting to the point where I'm not having to Google things so much. But honestly, there's no shame in Googling things at all. But maybe that's a good idea for a future stream. It's just some. I was thinking that might be a neat thing to do. It's just because I don't think anybody's really doing like challenge coding or challenge whatever. I mean, maybe I don't know. I'm not the biggest watcher of live streams, to be honest. I mostly stick to YouTube. But doing things like, you know, taking a shot if some condition happens while you're programming, or doing some sort of like timer where I limit the amount of time I can work on any one thing and then see if it all works. Not sure yet how things are going to go, but it's the idea for now. What we're going to do is, for each data frame, we're going to do something like, we're going to say ingredient 1 and then the name of the ingredient, just so it's a little bit more visible. This isn't technically necessary, but it makes seeing what our input is and what our output is much easier. So we're going to say something like I1 dash C for C. So this is all the ingredient encoders, or all of the ingredients, zeros or ones if it's this thing. And then what we can do is for I in range 6, we're going to add each piece. So we're going to say temp is equal to ingredient I plus 1. I plus 1. I'm keeping things simple for this first stream just because also I was having like a decent amount of technical difficulties earlier. Like, so I live in Japan, where I'm doing this stuff, and Japan has good internet speeds. Like, even like we live in a house here and we get like 2.5 gig, but the house itself doesn't have Ethernet anywhere, and I'm upstairs, so I'm live streaming over Wi-Fi. So I apologize if it's not the best quality at times. It's probably the most I can do without running a cord from upstairs down all the stairs across the room and to a router. So I think I would probably be murdered if I did that. So yeah, like it was failing and like cutting out right at the beginning of this. Like, I started streaming around like 6:45 or so, but it seems to be working now at least. I've been in Japan for a little over 2 years now, actually. Like, I got here January of 2020. I moved here to start a job that I got from the US. I used to live in Texas in the US, so more hints about who I would be. But I moved here, and then 3 months later, borders closed, and so I haven't really been around Japan all that much. I've been to Kyoto, which is neat. I went there twice, but yeah. Yeah, exactly. Like, I'm technically streaming at like 60 FPS, but that just gives you smooth scrolls whenever I'm going up and down my Jupyter notebook, so I don't think it honestly matters, so. But either way, like, it was cutting out earlier, and you know that's obviously not great, but at least it's functioning now. So now what we've done is we've created a list with a bunch of different pieces that all kind of look like this, where it's ingredient 1 and what ingredient is it, measurement 1, what is it, etc. So yeah. But I will say living in Japan has been pretty cool, at least just because of the fact that the company I work at has a huge amount of international people. So I went from living in Texas with mostly just other Americans to working at a company where my boss is from Egypt. I have a coworker from Turkey, another coworker from Morocco, and all over the place. And then of course plenty of coworkers from Japan. So it's been really neat. Yeah, so actually, I will say one good thing that happened for us, at least, is that we ended up, whenever we moved, I came here on my own first to just like a tiny month-to-month place that was like super expensive for like a studio apartment. And then COVID hit right as soon as my girlfriend came from the US as well. And we moved right as soon as COVID hit from the small place to a larger place. But since we all went on work from home, it actually was kind of convenient because it just meant instead of working from home, I could kind of move and do all that stuff myself and buy furniture and do all that. Tokyo, and so I don't know how much you guys know about the COVID situation in Japan or have heard, but yeah, it's not nearly as good as people claim it is on the internet. Japan's policy is just pretend it's not a problem. It's crazy. It's not being treated seriously at all. Everybody wears masks, and a decent amount of people are vaccinated, but boosters aren't available here at all. And people didn't get availability for vaccines until like 6 or 7 months after people in the US were. Like my family back in Texas, even like my extended family that I don't like to talk about in Texas, people were able to get vaccines well before anybody was here in Japan. They've just not treated it seriously. Yeah, like people are generally wearing masks, but the masks don't do that much when you're on a train that's packed like sardines. Like I just came back from work earlier, and our train was like shoved full of people. So it's just kind of a shallow attitude that people have had. I mean, I still wear a mask everywhere, and I'm fully vaccinated, but it's the most that I can be here. They don't do any real requirements. But anyways, we've got our data all prepped. This is kind of, if you're familiar with machine learning and stuff like that, this is actually kind of opposite to how a normal machine learning thing would look. Because normally, you'll have a lot of input columns and then have one output. So maybe you would have all these different possible ingredients, and then you'd be predicting the name. But we're going the other way around. We are going to be taking in a name and turning it into what different categories all these different ingredients should have. And I think that's kind of a neat spin on how a lot of these things normally are. But we'll see how it performs. And so our data is already prepped. Yeah, like we here in like Japan, like I guess, people are generally more sensitive about it, and like they'll glare at you if you don't wear a mask. I've seen people not wearing masks and they get the death glare by all the people on the train, but other than that, people go out, doing whatever into crowded places. They the Japanese government did not want to cancel the Olympics and refused to cancel the Olympics, despite a large amount of people wanting them to, because they weren't taking it seriously. But okay, so now that we've got our data prepped and we can actually use it, let's build the second half of the model. So maybe about an hour ago or so, not that much. Yeah, I'm thinking about having a Discord server for now, since it's, you know, just the three of us that are talking. I don't know how much point there is in making a Discord server right now, but it's something I've considered. I haven't used Discord all that much, actually, so I'm not the most familiar with setting one up. I was mostly just setting up all this stuff. But yeah, if there's you know, people who would want to have a Discord server or anything like that, then I think absolutely I would be interested in doing that. But yeah, so let's start our decoder model. So what we're going to do for the decoder model is the very first input is going to be something that should be the shape 128 by whatever. So our input I'm awful at typing, or maybe it's just that I had two like tiki drinks. Decoder inputs is going to be some sort of input where the shape is going to be 128 value thing. And then we are going to do probably just a couple of like dense layers to start. Just some basic like run-of-the-mill neural network layers that are just reading those 128 numbers, and then they're going to generate out what they think these should be. So first things first, let's do a dense layer. So we'll just say something like D is equal to dense maybe 64. Who cares? Dense 64 on decoder inputs. Just since we can, and it's generally, you know, not a bad idea, we'll do some like dropout layers. This just makes it so that the model doesn't overfit, because we are training on a very small amount of data, so overfitting is very likely to happen. So we want it to drop out randomly some of the inputs, so hopefully it can generalize enough to be decent. And then we can do another dense layer, why not? And then maybe another dropout. And so now what we need to do is we need it to predict out 12 different things that we are going to check. So there's kind of 12 outputs, even though there are, you know, 47, 82 different real outputs. It can kind of be split into 12 categories. It's the first ingredient, the first like measure, the second ingredient, the second measure, etc. And we want to do like an argmax on each of those to find out which one is it trying to do. So it's going to send out however many different columns there are. So in our case, since we're still just kind of doing things for, you know, just fun right now, we're going to go ahead and just do 4782, which is hard code it. But in practice, you could find that as a variable and calculate it directly so that you're not hard coding this. So this is going to output 4782 different numbers. You know what? Maybe that's not a good idea. Yeah, scratch that. I'm going to go ahead and make 12 specific outputs, each with that many numbers. I think that's a better idea. So what we can do is we can say something like I1 is going to be a dense layer with however many different ingredients there are. So ingredients encoder. Yeah, I guess that's what you could do, is you could try to make it reject existing combinations. I don't think it's going to get too accurate, to be honest. I think it's going to, at least from this first point of view, it's just going to end up being a little bit of nonsense or a little bit of random things. So we'll see. But that is something as well, is to kind of do some post-processing, where instead of just tell it find the most likely one, have it give you all of the odds of what it thinks you should use, and then filter out from there. And so if the top result already exists, it just gives you a different one. So yeah, and also like just more cocktails and more data. I'm sure there's more cocktails than 990. Like I'm sure of that there are more kinds of things. But that would just be, you know, more time, and that's not something I'm against doing, but for now it's just it's good to get something working, even if it's awful, rather than spend all day not doing anything. Okay, so what we're going to do is we're going to do ingredients encoder dot process. And these ones are going to get an activation of sigmoid because we want it to give kind of like a strength of belief 0 to 1 of how much is it thinking that you should use this ingredient for ingredient 1. And this is going to go on D. And then we just repeat for each of the different ingredients. So these layers are all structured exactly the same way, but we're going to train them to do different things. That I1 needs to predict what's in the I1 set of columns, I2 needs to predict what's in the I2 set of columns, etc. So even though these are all defined the same way, they'll end up being their own kind of thing. Now, they might end up using duplicates because of this. Like I1 will be potentially the same as I2 and potentially the same as I3. You know, that's something that's also kind of a drawback of this, but it is what it is. Okay, ingredient encoder. And then measurement encoder. Okay, and so now it's going to output in order each of these things. But since our data is structured in such a way where it's ingredient then measure, ingredient then measure, we should probably do the same with this. And so now our final decoder is going to be a model that takes in these decoder inputs and will output all these different outputs. And we can see, whenever we print summary, what's going on. And so it's got a lot of different outputs. Basically, it's kind of like a tree branching out, where it'll have the same inputs and then go out on the outputs. And our final actual model is going to be a model where it will take in the encoder and output the decoder. we might have to adjust it just a little bit. But yeah, so let's rename these things some slightly more helpful things. So decoder outputs, so that it's clear. And then let's rename our original model stuff so that it's more clear. Alright, see ya. Have a good rest of your day. I have no idea what time it is for you, but, you know, cheers. We're getting pretty close to having something that we can just train. So now we've got this encoder inputs. Ooh. I'm still using the old stuff. Graph disconnected. Ooh, I think I'm still using M somewhere. Yep. There we go. So it's going to be taking in these inputs and going out, and we can just go ahead and construct the full model, which is actually going to be the encoder inputs to the decoder outputs. I need to remove that. This needs to be built off of encoder. Actually, instead of doing this as two completely separate things, I'm going to go ahead and just build it all as one model. And I think that's probably reasonable. There's no reason why it actually needs to be two different models, an encoder and a decoder. That's just for visual purposes. And the final model is going to be going from encoder inputs to decoder outputs. There we go. That works. So doing it all in one rather than splitting into multiple parts was definitely the way to go. Yeah, so now we've got an input layer, which this like none by one. The none is like the batch size. So you could give it a list of strings. And the one is just the fact that it's a string. And then it's going to be split into numbers based off of what kind of label of the string has. It's going to be turned into an embedding, which is basically just a high dimensional vector space, whatever way of interpreting a string. So that similar words have similar vectors and opposites have faraway vectors. They tend to have the property where if you did something like the difference between boy and girl is similar to the difference between king and queen. Concept like that. So differences in relationships between words are preserved in this embedding space. And these are all pre-trained so that we don't have to train all this stuff from scratch. Then we have an LSTM, which is just going to be reading up all of these words in order and turning it into just one vector instead of a list of vectors for each word. And then we've got all of the dense dropout part, which is just kind of learning from the sequence what to do. And then just a bunch of dense things that are predicting which ingredient to use and which measurement to use. So that's our full model constructed. I've been streaming for about an hour and a half, and we've got a model now. So the last part to do is to train the model. As a sanity check, what we can do is we can kind of just train it on the whole data set rather than doing a holdout and a validation and a test set and whatever, just to see if it runs. Because even if it's not performant and it's not good to train it on your full data set, that will give you an indication if things are kind of working right, if it performs as well on just the pure full set on its own. Because if it's not giving any reasonable answer and you're training it on your entire data set, giving it less data is certainly not going to help. So we have all of these staggered outputs. We have 12 different outputs specifically. Ooh, forgot one. 6. 12 different outputs. And this is going to then be trained against these things. Yeah, exactly. Like if you can't overfit, if you can't purposefully cause a problem, then something's gone wrong. Or maybe you just don't have enough data. Like it's entirely possible that 1,000 cocktails with all the different parameters just isn't enough to do anything. And you would need to do things like find more data or do slight alterations, like make, for this apple pie, manually go in and say, okay, I'm just gonna add like different rums or reduce your space. Like there's things that you would have to take into consideration, that maybe your training set is just not shaped in a way that you reasonably can find good information. It might not be that you've done something wrong, but maybe that you're expecting too much. So we've got this, and now we just need to compile the model and train it. So I'm trying to think if we should do it one at a time or all at once. I guess probably all at once would be ideal, but I'm going to go ahead and refresh Keras model train with because I want different losses for different outputs. Okay, so you just give a dictionary. That's perfectly good with me. Okay, so all of our losses are just going to be sparse categorical cross-engineering. No, categorical cross-engineering, because our data is actually categorical. We didn't actually have to split this out for Keras. There's a way you can do it in a sparse way, and then your data's a little bit more compact, but it's kind of clearer to know what's going on if you just go ahead and transform it out. From a performance perspective, I'm pretty sure they're exactly the same. But let's go ahead and compile the model. So our losses, let's do this. We need to add names for each of these. There we go. It's more clear now in the summary too, how we've got all of our outputs. And so our losses is going to be a big dictionary where for each of these things, it's going to go to categorical cross entropy. We're treating them individually because each one needs to predict one thing. Each set of like 600 whatever is predicting one thing. If we treated it all as one, then by default it's going to assume that there's only one answer across all of the ingredient and measurement columns. And that's not what we want. So it's kind of simplest just to split it all out and then have 12 losses and 12 things that you're measuring, and then backpropagate that way. I'm gonna go ahead and take a like 5-minute break real quick just to go to the bathroom and come back. And once I come back, I'll finish up the losses and we'll run it and we'll see how it does as a first pass. Alright, I am back now. Okay, let's finish up this model and get it training. At least it's good to finally be putting this computer to use. One of my bad habits during this quarantine, or at least maybe that's my excuse, is I have spent way too much money on a computer. Basically, that became my hobby. That's all I was doing was working on this computer and improving it. And then I used it for nothing productive. But now at least this is something productive. So our optimizer is going to be Adam, and then for metrics, we're going to have a couple of different metrics. Yeah, so actually I found some 3090s here. However, being Japan, and also during COVID, they are insanely expensive, like $4,000, $5,000. So then, while I was tempted, I was not going to do that. I then looked into like the kind of more workstation graphics cards, and I found out for the time I was looking, the workstation graphics cards were exactly market suggested retail price. There was no scalping going on whatsoever for the workstation ones. So I ended up grabbing a RTX A5000 graphics card at exactly retail price. No problems whatsoever. Next day delivery on Amazon. It's still an expensive graphics card. Don't get me wrong. Like it's still more than I should have spent on a graphics card. It does not get nearly as much use, but it half the cost of a 3090, yet basically being the same thing with workstation drivers. It's probably the best you can get during COVID times. But it's an RTX A5000. It's a like workstation graphics card. It's still by Nvidia, and it's still whatever, but it's kind of like the workstation equivalent of a 3090. It's got the same amount of RAM, and I think it's slightly weaker when it comes to games, but not that I would notice all that much because the 3090 is already overkill for games. But yeah, so now let's try this out for compiling the model. We've got our metrics, we've got our optimizer, we've got all that, and now we're going to compile it with everything. So losses equals losses, metrics equals metrics, optimizer equals optimizer. Sorry. Or let's just see if that runs. Oop, type error. Invalid keyword argument. Incompile losses. Oops. Oh, it's just loss. Alright, and it works. So, at least as far as Keras is concerned, it thinks things are good. Now, the final test is just, will it train? So let's go ahead and get our X and Y. So our X is going to be data dot, because I'm lazy, or just data name dot values, and then our Y is going to be data dot ilock all rows, one on for the columns dot values, just to make sure that that works. X is all of these names, and then Y is all of these ones and zeros. There we go. If I have to split them up into individual vectors, if I have to split Y, that is, into the 12 pieces, that's not a big deal. I wouldn't be surprised, but let's just see if we can do a simple model.fit Y, epochs equals, I don't know, 3, and verbose equals 1. Oop, yeah, probably. Yep, okay. So we need to split Y up into our 12 pieces. I was kind of hoping that it would just kind of know that if you've given it something that's concatenated, it'll just split it up for you. Can't say I'm surprised that didn't work. Oh well. So we'll do it in a smarter way. So what we can do is we will do something like Y is that, and then for I in range 6, temp is equal to data call for call in data.columns if I plus 1 in call y's dot append temp dot values. We'll see if this works. This is only assuming if this whole whatever thing works. So we'll see. Did I do a separator? Yeah, I did a space and then a dash and then a space. So that should be unique. I don't know if there's any M2 space dash space alcohols, so. None type is not callable. I guess we can do it as a dictionary. Or I guess maybe we need to. Goodness, none type is not callable, but why? Well, when in doubt, let's just restart model cells. Maybe models got messed up. So we're getting something slightly weird in our model. I think we just have a typo somewhere, I would guess. Because I think we're almost there. And then we'll be training the model. So far we've got the... Let's just see... Let's do something like this. Assert temp.values.shape is equal to the len of ingredient encoder dot classes. That's what I called it, right? Yep. Okay, yeah, so that's what's going on, is we're pulling too many. That's odd. That's kind of annoying, too. I guess we'll do something else, then. It seems like I yes, let's print this out to see exactly where it's going on. If that's the problem, raise a runtime error. Too many columns full. Problem on. Interesting. It just had failed, but now something's going weird. Oh. Yeah, duh. Okay, so that's interesting. It's pulling exactly the right columns, but this none type is not callable thing is kind of weird. I think it's just whenever it's failing, the model's getting corrupted. But I think that's just something throwing us off. Cannot squeeze dim1. Expected a dimension of 1. Got 688. So something's expecting a dimension of 1, which, as far as I'm aware, the only thing expecting a dimension 1 is exactly that. So this is expecting a dimension of 1, 688. Let's see, what's our input? Is x. What is x? Is a 990 by 1 vector. Well, one thing that we can do is we can even just run it on x and see if our input is making sense. So we can actually say model run on x, and this will compute x. Now it's not been trained at all, but this is the results. So our current outputs is indeed 12, untrained out, and then let's check the different shapes. So at least untrained out 1 is a tensor of shape 990 by 688. What is wise I1 though? Is a 990 by 688. Okay, so that makes sense. So let's shape dot numpy shape 0. Okay, let's just do for I in range 6 rows. We actually only care about columns because it's probably the columns that's tripping us up. So the columns is going to be actual calls. That. Or how about expected? Expected columns. This is how many it's going to be expecting in the actual model. And then we'll say given calls is equal to this. If expected calls is not equal to given call, raise runtime error. Problem is with I plus 1.
Well, here's the sleep shop's answer.
Oh, yeah. That's probably what it is. Yeah, I just mixed them up. I used categorical cross entropy and categorical cross entropy. Thanks for catching that. That's what you get from copy pasting from Stack Overflow. I caught it with the loss, but then I just copy pasted from Stack Overflow for the accuracy, and I wasn't thinking. Man, that I mean, I guess we probably would have caught it eventually, but that was not too fun. Oh yeah, let's recompile the model and try again. And there we go. The model's technically training. Now, we just ran it for 3 epochs. But let's do it for real, I guess, on more epochs and see what it comes with. I guess that's the strength of streaming while you code, is that maybe some viewer will find exactly where you've made a dumb mistake, and then it'll get it working, instead of you spending a bunch of time trying to debug something that's impossible to figure out. Okay, so I'm going to... What I like to do once we've got like something at least end-to-end working, in quotation marks, and that is a kind of thin quotation marks, is just restart and run all cells. That way we make sure that we are running on exactly what we're expecting to run. We're not doing things all over the place everywhere. And instead we are, kind of being reasonable about this. So what we're going to do is let's, instead of doing epochs equals 3, we're going to do epochs equals 100. And we should probably do some sort of like early stopping, but that's for later. So let's just restart and run all cells and see where it goes, and if it gets stuck somewhere, then we'll fix that. But otherwise, we'll just run it and have it make some cocktails. I was not expecting to get this far this fast. So who knows? Maybe it'll even have some amount of sane-sounding cocktails, and I'm going to have to go and make some drinks. I mean, it's 9:30 on a Thursday where I am, so I guess it's probably okay. But who knows? Oh, and since we're using TensorFlow, TensorFlow with modern versions of TensorFlow will automatically use the GPU. So this is training on the GPU, and we can even check out if it's even being hit that much on the GPU. And it seems like we're perfectly fine. It's TensorFlow by default eats up your entire GPU memory. So that's not something to be alarmed about. That was something that kind of worried me at first, was I assumed that like since that was hitting it, the model was like throttling it. But no, it'll just use all of your memory and reserve it for that. So it is possible that like the stream quality might go down a little bit because it's just using as much as it wants. But if that's the case, I'll just stop it and then run it with limited memory. Yeah, exactly. Like there's a way you can do a limiter where you just tell it how much RAM you want it to use at max. But by default, it will claim all of it. Other stuff will still work, but it might try to use other stuff. And generally speaking, though, at least from my experience, if it tries to access something that somebody else is using or some other program is using, TensorFlow will be the one that fails. So it won't crash your other stuff, but if TensorFlow tries to use more than it's actually available to it, it'll just fail. So, I mean, you know, honestly, looking at just a bunch of numbers scroll by is not the most exciting of content, but we can see that some of the accuracies are actually getting fairly decent. Now, the reason why some of these accuracies are getting somewhat decent, like we can see that ingredient 6's accuracy is at like a 90% accuracy. That's because most cocktails don't have 6 ingredients. So it's predicting that you're not going to use an ingredient, and that's probably accurate over 90% of the time. We can check that after the model finishes training to see real world what are these numbers meaning and are these any good. But as for ingredients that are always there, the ingredient 1 output accuracy, which every drink has an ingredient 1, is about 50% accurate, which isn't bad. Now, it's probably overfitting to the data, and we're training it on all of the data, so that makes sense. But, you know, for a first thing, ingredient 1, it's right about what ingredient to use 2/3 of the time. This could give some fairly reasonable cocktails. We could at least test it on things that it should know. We can say, you know, what's in an old-fashioned, and see if it says, what is that? Whiskey and orange? I don't know a lot of classic cocktails. I'm not too ashamed of it, but I'm a sweet drink person. Like give me a bunch of simple syrup and a bunch of fruity things where I don't taste the alcohol at all. Okay, the model finished training, and so some of the accuracies got really high, but again, we expected that for ingredient 6 because the vast majority is NAN. But honestly, for how little effort we put into the machine learning part, having something that at least is getting to 70% accurate on this, on very little training data, is not a bad model. And now we can even say, hey, what's in a very popular drink here in Japan is called a lemon sour. Let's see if it knows what's in a lemon sour. Oh, right. We are going to have to post-process the output. So unfortunately, it's not immediate, right? It's not going to be immediately perfect. We've got to take the output and then transform it a little bit because this is the raw output of the model. But it's not that bad. So we'll say predicted ingredients is this. Predicted ingredients is going to be a list that has 12 items in it. And for reference, so that you'll know what to expect, a lemon sour is typically like lemon juice and some kind of alcohol, whether it's like vodka, or here in Japan, since it's Japan, it'll be like shochu or something, and then like soda. So it's just like basically alcoholic lemonade, pretty much. So it should be, you know, we should see that it asks for lemon. If lemon's in the name, it should probably put lemon in the ingredients. If it doesn't have lemon anywhere in the ingredients, even if it's a completely different drink, but if there's no lemon anywhere, then the model probably isn't learning to do that well. Because if somebody asks for a drink with lemon in the name, lemon should be an ingredient. So we'll see. Now what we'll do is let's just create a function just because it's probably worth it. We'll probably want to try multiple different things and see what it does and what drinks it invents for us or has memorized if it's in the training set. So create recipe and the description or the name is a string. We'll fill out a doc string later. That doesn't matter. So it's going to predict the stuff using the name. And then for output in predict, or I guess we'll just go for I in range 6, just like we've been doing for everything else. Ingredient is going to be equal to predicted ingredients 2 times I, because we have them staggered. And measurement is going to be equal to predicted ingredients 2 times I plus 1. These are vectors of all the different predictions for each of the different classes. So we need to know which one did it predict. That's a simple argmax. So we're going to say ingredient is equal to np.argmax of ingredient. Just resetting it to the same name so that it's fine. Then we need to turn it from a number of what ingredient it is into the actual human readable format, and we can use the encoders that we created way back when, these measurement encoder and ingredient encoder, to get that back out. So we'll say measurement encoder, or measurement is equal to measurement encoder dot classes measurement, because the classes is an ordered list of like 0 is this, 1 is this, 2 is this. So if we have the number, the index of what it is, we can immediately go back to the class name, the string, using this. And we'll repeat once again with ingredient. And now all we have to do is save these back out. So we'll say something like recipe is equal to this, and if ingredient what did it call nans? Did we just call it nan? Nan, continue. So if it just predicts nan, we're going to continue. We're just going to skip that row because it didn't want you to add anything. Otherwise, it's going to add to the recipe. It's going to add measurement of ingredient. Return recipe. So let's see what it thinks we should do for a lemon sour, if it even works. All right, that's not a bad recipe. Now our nan skipping thing didn't work for some reason. We'll need to check that. It's probably something to do with the string comparison. Let's do like dot strip dot lower float attribute has no. Okay. It's literally becoming a nan. There we go. So just as I was saying, you know, a lemon sour has lemon in it, some kind of alcohol, and simple syrup. Now it didn't give the soda, so I guess we can take points off for that. But it gave a lemon ingredient, so that's not bad. I guess another one, maybe one that isn't such a hint in the name, Moscow Mule. There we go. Another one that, now, it didn't know how much ginger beer and how much lime wedge to add. But it got the ingredients. A Moscow Mule is vodka, ginger beer, and lime. Typically, you would probably do one or the other, but maybe it just likes giving you a garnish and telling you, hey, add a lime wedge on there. But a human could absolutely read this and create a drink out of it. Yeah. So what, I guess, you know, you're still here. What would you want to see it create a recipe for? If you have any ideas, I would be more than fine adding and seeing what your created drink is. But, yeah, so I'll keep trying others as well. Oh, you don't know drinks? Well, I mean, yeah, but this doesn't have to be a real drink. You know, this could come up with something entirely on its own. Right? Like, maybe you want a, I don't know, like maybe like a non-alcoholic drink. Like, maybe you want like an orange soda. What does it say is inside of an orange soda? I don't think this makes sense. I don't think Scotch whiskey makes an orange drink and ginger ale. But that's what it thinks goes in an orange soda. Or like what's in a root beer float? 2 ounces of vodka, 1 ounce of sugar. Okay, so probably not accurate. Yeah, Coca-Cola, Blanco tequila, and triple sec. I don't think those are the secret ingredients. But hey, you know, like, I think this is just an artifact of our overfitting and our training. So we'll see. Does it know rum and coke? Okay, yeah, I think it's just overfitting, because like rum coke, that's where it got like rum, carbonated water. It's like getting closer, like a rum and coke. It's like kind of, it's like almost there. So absolutely, you know, great results for a just, you know, no effort model. It's at least doing something. It's coming up with somewhat relevant ingredients. If you tell it exactly what alcohol you want, like how about just rum, vodka, gin? Oh, okay, so it got the rum, but it didn't put the vodka and the gin in it. It thinks that you just should have rum, lemon juice, and simple syrup. I mean, that's a drink I could make. I have rum, lemon juice, and simple syrup. Does it have my name in it? Probably not. Oh, you know what? This makes sense. I think whenever it's seeing unidentified words, it's going with this tequila triple sec thing. Because I think it's seeing words that it doesn't know and isn't in the vocab. And so it's breaking it because it's completely, it's out of vocab. So it's just giving like an empty list. So that's not too bad to fix, because we did it in a dumb way to start with anyways. We, whenever we first created the text vectorization, way back up here, we taught it only words that showed up in real names of drinks. But that's not all of vocabulary. That's just the already existing names. So what would probably be better is to, instead of adapting it to understand only these words that show up here, adapting it to all of the vocabulary that shows up in maybe a book about cocktails. or like reviews about scrape a bunch of reviews about cocktails and see all the different language that shows up there, so it knows all of those words. Because we tuned the text vectorization, like the vocab is get vocabulary, or just is relatively limited. Like it's got a decent amount of words. Like if we check, it has about 1,000 words, but your average fluent English speaker will use it's 30 to 50,000 different words. So 1,000 is nothing compared to 50,000. So maybe that's something we can find. Maybe we can find the same vocab that goes into just glove to begin with, and then all 400,000 of those words we'd also be able to use for our model. So that's what's causing it. But for now, while we're just playing around with it, it means that these are the words we can use. So maybe we use I don't know, what's a blizzard bloodhound? What's in a blizzard bloodhound? Gin, brandy, dry vermouth, and orange juice. I don't see what gives it the name. Maybe this drink would appear somewhat red. I don't know what makes it blizzardy, but maybe that's where the ingredients would come into play. I don't know what either a blizzard or a bloodhound is when it comes to cocktails, but at least these words will probably give more meaningful results than a lot of others would. We can try cider. That's a common word for alcohol. What's a blizzard cider? Brandy, lemon juice, and orange juice. What's just in normal cider? Brandy, milk. That does not sound like a pleasant drink. I don't think that's how you make cider. I don't think it's 2 ounces of brandy and 1 ounce of milk. I don't think that's the kind of drink I want to make. But, alright. But yeah, so this model is now technically working end to end. So the next step is to clean it up a little bit so that now we can more easily improve the model over time. So I think that'll be the next step, is just kind of reorganizing some of this stuff and turning it into a script that once it's pushed to GitHub, anybody can play around with. My goal is to make every project that I do something that people can play around with. They just download and run it, and they can see how things are working. So, there's if this were to be some sort of industry tool that is actually predicting cocktails for paying customers, this is not good enough. This definitely needs lots more effort. Maybe some manual data cleaning to see if there's duplicates. Because here there's 2 ingredients in a single thing. There's lime wedge and superfine sugar. Maybe you would manually split that out into 2 ingredients. And then the other thing is that we're not telling the user how to make these drinks. So maybe they'll just mix these drinks together and they'll be gross, but the AI had some idea in mind of if you do these in a certain way, it'll actually come out good. So there are multiple ways to improve it, but before we dive deep into improving anything like that, we want to take some time to clean it up and turn it into something that just anybody could use by pulling the code on GitHub. So I like to develop things in Jupyter Notebook, but Jupyter Notebooks are not a production grade thing. So the first step is just to create a bunch of functions. So what we'll do first is we'll do some sort of data processing function that'll take in the data path, which is a string. And this is going to read the input data and transform it into the structure needed for training a model. Inputs. Data path. A string path to the input Mr. Boston cocktail dataset. Which I guess we can even check, where did this data even come from? Like what is this? They didn't seem to give any explanation on Kaggle what this is, or it's in the public domain. So, I mean, the stuff that we did, copyright law is a little bit shaky in machine learning. I'm generally of the belief that if you're training a model off of something, that's transformative, but we don't have to worry about it. It's in the public domain. Guess I probably should have checked before I did all this. Oh well. But, oh, from the most, yeah, I wasn't looking up there. Oh, in that case, since this was updated 3 years ago, maybe there is maybe there's more recipes. That we could download. Now, I'm not really seeing API about the guide. Discover recipes. So that's where their category is coming from. So, you know, some digging could try to find what this API is, or if they even do the API anymore. Who knows? This was 3 years ago, and they said version 13, or no, this is just, they've updated 13 times. And, you know, who knows, maybe taking this Jupyter Notebook, cleaning up, and then I'll upload it to Kaggle. That could be a decent idea as well. Nobody seems to really be doing anything other than just some very basic exploratory data analysis. And this was a pretty self-contained project, just off of one file. I think for making it better, definitely over the next couple of weeks, I'm going to spend more time finding different ways of doing it, but it seems to be in a functioning state. Yeah, I see that we have some new viewers as well, potentially. We just trained a model that can create a cocktail recipe given a name. Right now, we just did it as a proof of concept. It's bad, but it runs start to finish off of some training data, and you can give it a name of a cocktail you want to see, like a lemonade, and we'll see what it's saying. In this case, to make a lemonade, it's saying you need some citrus flavored vodka. Okay, that kind of makes sense. Some grapefruit juice. I guess that's the wrong citrus. Fresh lime juice. Also the wrong citrus. An egg white. I guess if you want like a kind of frothy drink. And then more fresh lime juice. Because 1 ounce wasn't enough. So obviously, it's not perfect. This is not a real recipe for lemonade. And this sounds not... I mean, it doesn't sound terrible. It just sounds like a bunch of citrus that isn't lemons being called a lemonade. And then an egg white to make it frothy. Which, you know, who knows. But it has turned a string name of a drink into an actual drink. Again, another drink that's very common in Japan, where I am, is a lemon sour, which is basically just like a lemonade with soda and like shochu. And here it's getting somewhat similar. It's saying you need lemon and sugar and like gin. Grenadine is not a common ingredient. I've seen it with gin. I've made it with gin at home. And simple syrup. It's missing the soda, which Lemon Sour in Japan does not have egg white, which is, I'm surprised that it didn't say egg white. I don't know if that's a good thing or a bad thing, because sour normally means egg white. But it just added grenadine and it didn't have soda water. So it's getting pretty decent, and there are plenty of ways that we could improve it. If you have any ideas of things to put in and see what it can make, let me know in the chat. Anyways, I just saw that there were more viewers, so I needed to pander. Gotta get those 2 other viewers. But yeah, so let's clean up this data and upload it to GitHub and make it something that anybody can use without asking me personally. Outputs, this is just going to give us the data frame as this format with all the different columns. So it's just going to be a pandas data frame. Okay, so now we can, I'm going to go ahead and save this, and I'm going to make a duplicate of it just in case things go horribly, horribly wrong. It's always a good idea. And then let's get started and just cut and pasting. So we read the data. This stuff will happen later. This stuff will also happen later and later. There we go. We also need to pass back out the label encoders so that they can be used later, because we're going to train them now on the input data, but they need to be able to be returned back so that eventually they can be used. And then lastly, this pieces. And this pieces will give us exactly the data that we need. So at the end of this, we just have to return data and then the 2 encoders, which is going to be ingredient encoder and measurement encoder. Yep. So let's do. It's going to be a tuple of a data frame, a label encoder, and a label encoder. Ingredient encoder. There we go. And then we're going to have another function that's prepare model. And we'll pass in data. It's going to return a model. And maybe some other things. For now, our output sequence length is 5 because we're assuming any name of a cocktail is 5 words or less. If we wanted to support bigger, longer cocktails, we could do that, but I think that's fine. And we might bump up max tokens to more once we can adapt this better. So a potential to do is instead of using the names to adapt, use a more general text source. That would be a definite way of improving this model. Okay. And, you know, we'll want to make a lot of these hard-coded things variables, but for now we're just cleaning things up. We can get rid of any sort of print statement. That's where it's getting the embedding matrix out of it. And then now we create the model. We need the encoders to know things about this. So we also need the ingredient encoder and the measurement encoder. Yep, so we also need those. And then the last thing that gets done in this one function, and this could be split into more functions, but is the losses. This is all fairly related. It's all having to do with getting the model ready for use, but oh well. So now it gets compiled. So now this will return the model. A compiled and ready to train model. The last thing would be a function to fit the model, which we need to again pass in data. We need the ingredient encoder, the measurement encoder, and of course we need the model. And this is just going to return back the same model to you. Not strictly necessary. In fact, probably not necessary at all. Maybe we'll just have it not return anything. And again, we'll write some docstring about it. Then we'll add things like early stopping and validation sets and all of that. All that wonderful, good stuff. And then we already did create recipe, but we need to pass in the other things as well. So in addition to a name, we need to pass in the model. We need to pass in the ingredient encoder. And the measurement encoder. And then that will be enough, I think. and it will return a list of strings, which are each of the steps in the recipe. And now the last thing to do, since we just reorganized a bunch of stuff all over the place, is make sure it still works. Because otherwise we just broke something and now we don't have a model anymore. So let's see. We need to pull data, ingredient encoder, and measurement encoder from this data processing, which, we will get rid of the hard coding in a little bit, but Mr. Boston flattened .csv. We're just going to restart and run all cells real quick just to make sure that this is still working. Alright, so that part ran and it finished. Then we need to prepare the model. Which is going to just return the model. Just to do it, we'll say model.summary. And that will chug along and run. Oop, name error. DF is not defined. We need to change it to data instead of DF. We're almost there. And then the last step is just to retrain the model, which last time we just trained on all of the data because why not? And again, this time we're just going to train it on all of the data, but to verify that it's working, rather than waiting the 100 epochs, we're just going to do like 10 epochs. And who knows, maybe it'll even work better since we're not training it for so long on just the exact same data over and over again. And in order to make this something that your general person would be more comfortable using, we'll want to have like progress. So like a function doesn't just run and it sits there silently. Instead, it will be printing progress. Like this is what's going on in the model. And now the model's going to train again. It's improving and increasing all of its accuracies. We might want to. It's probably good to have that NaN column, but the accuracy doesn't reflect reality too much, because I think most of the time it will end up not predicting any ingredient for those last few ingredient slots where there are mostly empty, because most cocktails have less than 6 ingredients, so the vast majority is NaN. Alright, so now we've fit the model again, and then the last thing just to test to see if it's still working is create recipe, where we are going to pass in, again, let's see what it does for a lemon sour. We'll pass in the model, the ingredient encoder, and the measurement encoder. 2 ounces of vodka, 1 ounce of powdered sugar. So 10 epochs was too little. This sounds like another classic drink of the model. Just 2 shots of vodka, or maybe I think a shot is actually like 1.5 ounces. So a little over a shot of vodka and a shot of powdered sugar to help that get chased down. A pleasant experience, I'm sure. So that just is because in order to test it, we cut down the training time drastically, so it doesn't make sense anymore. But earlier, the results were significantly better, so we'll just run it again with more training time. now that we know everything is working. But now that we know that everything's working in this consistent way, the last thing is just to create a main function that then is going to be running each of these things. Now, while we're kind of playing with it, you might not want to have a main function because that means you're only going to be running it a little bit, or you'll only be able to check out one recipe at a time, really. But it cleans it up. So there we go. This code is packaged up, and it's in a way where it's repeatable and clean, and it can be saved as a .py file, and no problems about it. Push to GitHub. A happy experience. There's a lot of things that we need to adjust, though, because a lot of this stuff is hard-coded. We want the user to be able to experiment with it, see what increased training time does, see what a better vocabulary does, and different model sizes. Maybe the model size is bottleneck. Probably not for this. It's probably our lack of training data, but we want to make a lot of those adjustable. So let's start with maybe the fit model thing. We can give a epochs, which is going to be a int number set to 100. And then we can find more data that's structured in the same way, or even manually go and find data and add it to our list, to maybe add as like a validation set. So data that's from a different source to check out as validation data to see how it does on data it hasn't ever seen before. I think the first and foremost way of improving it is improving its vocabulary, so it can just generally give a lot more cocktails. Our vocabulary is currently limited because we basically told it the only words that exist are the words that exist in current cocktail names. And there's a lot more words than the words in current cocktail names. Especially because 90 of those words don't appear in our pre-trained stuff, so those get lost. So it's actually even fewer. So what we need to do is we need to be a little bit better, and instead hang on, is this okay? Yeah, so it's getting zeros if the word's not in the vocab for those 90. So that's what's going on. Oh yeah, it says it right there in English. Words not found in the embedding index will be all zeros. Maybe not a good idea, but it's probably fine for now. Okay. So instead of using the name to adapt, let's use a more general text source. I guess let's do that. Let's see if we can't find some sort of cocktail book PDF or something. Because that'll have a lot of the kind of flowery language that's describing cocktails, and so that'll have the names of cocktails, and that'll have like the words that are relevant for naming them. But it'll also have words that go into describing cocktails. So you could use those words as well to build something. Because as it is right now, unless your word is in that 1,000 different names, it's just going to be a bunch of zeros to the model, and the model's just going to give you nonsense. For example, if we put in, my name, which everything is still in scope, so we can do this right up here. Yeah, it seems like 1.5 ounce of vodka, 1 ounce of dry vermouth is its signal that it's not in the vocabulary. Or it's its signal that it's, not training very well. Because if we also give it an empty string, it's doing exactly the same thing. So it's not trained very well because we shortened the training time. So yeah, let's find some sort of maybe like a cocktail review. Cocktail reviews is okay. This is not what I wanted. Cocktail review dataset, maybe? Here's somebody else who did some other kind of project involving cocktails. This is a recommendation. So, given your liked cocktails, it probably recommends you existing cocktails. Yeah, they're finding similar cocktails given your input cocktail, which is a completely valid thing to do as well. But we're more interested in giving a name of a cocktail instead of just finding things that are similar. Coming up with the ingredients list, even if that name doesn't actually exist. So they used, these are also ingredients and recipes. I was hoping that maybe this would have reviews, but I don't think that it does. Reddit. There we go. Somebody else has looked for cocktail reviews in the past. Food.com recipes and reviews. This is not a bad idea. Like, it's a little bit more general than we were looking for, because it's just food in general. But food will also have that kind of flowery language that we want to support. So, since we're not using it for actually training the model, we're just using it for vocabulary. It's not a bad idea to just pull the text from the reviews. If they have them. Let's see, PP recipes, raw recipes. This has like general things like recipes, and maybe this would be an interesting way of improving this model, or making this model more general, because we did it for cocktails. This is for like just general recipes, and that would be good. So this has descriptions of of recipes, so that will be all sorts of flowery language. So this could be a not half bad idea. And then the last thing that we can also try is using the instructions. But the instructions won't really have flowery language. The instructions will just instead have, crush ice, mix in drinking glass. But those aren't things that you want to use to describe a cocktail to the AI to ask for something. Those are words you would want it to give you. So I think maybe pulling this description column is certainly better than what we have right now. And may as well do it. So let's download this data. It's pretty large, 294 megabytes, but it has a lot of extra stuff that we don't really need. We just need this description column, and then we're going to just feed that directly in. So I'm copying it over. You can see it's in there right now, and all the code for this is going to be pushed to GitHub. Links for the GitHub are again, in the about page on my Twitch profile. It's Volander AI is the name of my GitHub repositories, and all the projects that I'll be working on over the next year while I'm doing this at least will be pushed there so that you can play around with them as well. All the development time is spent on Twitch, and the highlights and specific tutorials, and then summaries of a project once a project's done will be edited and put to YouTube. as well as a bunch of blog posts. Anytime there's a tutorial or general project will be going on my blog, which there's also a link on my profile as well to check out. Right now there's not much because this is my first stream, but you know, if you're interested, you know, give a follow and participate in chat and hang out, and we can build AI. I just started this stream only like 3 or 4 hours ago, and we've already built one AI that can do really bad cocktails. So it's only up from here. Anyways, that's finished downloading, and my spiel is done because I noticed there were more viewers. And now let's do this raw recipes way of improving our data's vocabulary. So all we need to do for this, for now, we're just going to be very dumb about it. We're just going to say something like extra vocab is equal to pd.read CSV. And this file is called rawrecipes.csv. So I'm going to copy that, paste it, and all we care about is the description column, because this has the flowery language that everybody pads their recipes with, so that their, you know, search engine optimization is as good as possible, and everybody has to scroll through for hours to find the actual resume or recipe. Don't know why I keep saying resume. Maybe that's a sign that I should be looking for a job. Who knows? Anyways, there's an extra vocab, and now what we're gonna do is we're going to take this extra vocab. We're going to treat it as a list, and we're going to take the name vocab, which is our existing like kind of name data, our training names, as a list, and we're just going to use both. So that way, all of these words are words that are valid words for recipes, instead of just some of them. And let's go ahead and bump up, instead of having 10,000 maximum words, let's do 20,000 different words that can show up, because that's more in line with you know, the general English language, instead of just 10,000 words, because we kind of want some specific words. In fact, maybe it's worth it to do even more, but we'll see how many tokens it can find in this. In fact, let's go ahead and just say print found and evoke different words. Let's run this stuff again, and now we're going to be using 100 epochs of training. Let's just go ahead and, instead of doing main, restart and run all this. So this is going to retrain the model once again, and then print out what it thinks a recipe for a Moscow Mule is. But now, instead of just using the name data for our vocabulary, it's going to be using a bunch of extra stuff as well. And I guess I'm going to go ahead and say fingers crossed that this works, because if I have the ingredients to make this Moscow Mule, I'll make it and see how it is. So here's hoping it's not... oh yeah, so there we go. Using that new data source, we now maxed out our 20,000 different words. Before, we said limit yourself to 10,000 words, and it only found 1,000. Now we told it limit yourself to 20,000, and it found more than 20,000. So that's really good. That tells us our model will be a lot more available to new words. We still probably need more training data, but that just comes with time and with more data sources and maybe variants of different recipes. That might also be a good idea, because there's no real one recipe for any cocktail. There might be slight alterations and different ingredients and all of that. Yep. So the model's training now. Unfortunately, since this is just a speed run of programming, that could be another decent idea. Do like programming speed run. Something. It'd have to be something repeatable. But like, you know, with some amount of challenge to it. Like we don't have pretty visuals of the training. Instead, you just get a bunch of text. But what's going on here is that it's showing what step of the training it's on, and then it's showing a progress bar for that step. It's telling you how long that whole step took, and then there's a bunch of stats about how good the model is now. Everything that says loss is basically like error rate. So bigger number is worse. The more loss there is, the worse it is at predicting that. The way that we've named things, I1 means ingredient 1, M1 means measurement 1, so how much of ingredient 1 to use, I2 is ingredient 2, M2 is how much to use, so on and so forth. And then instead of loss, there's also accuracy, ACC. This is like a number 0 to 1 of how accurate it's getting. So at the beginning, you can see for ingredient 1, it's miserably bad. It's right like 8% of the time. But after 50 epochs, it's now right 40% of the time, which you don't actually want 100% accuracy, because that means it's probably just memorized the stuff. It's a bit like if you were studying for a test and you just took the textbook and memorized it word for word, and that's all you did. If you purely just memorized a textbook word for word, you probably wouldn't actually understand the stuff and be able to do new things. So instead of wanting to memorize every single word in order of a textbook, instead you want to learn the lesson that the textbook is trying to teach. Same thing applies to machine learning. It's, you know, any kind of concept you think of for humans learning kind of also applies to machine learning. You want to teach models in a bunch of different ways. You don't want them to just memorize for the test. You don't want to study for the test. You want to be able to test their actual knowledge and not just some review, etc. All of those ideas of a good education apply to a good machine education. So right now we're not doing things in the right way. We're just doing things in a simple way so that we can have something up and running that then we improve and improve and improve until it's giving completely reasonable cocktail recommendations. But it's almost done with about 100 steps of training, which the first time we did gave somewhat reasonable results. And there we go. It gave completely reasonable results. We can see that the recipe it created for a Moscow Mule has 1.5 ounces of vodka, 1/2 ounce of fresh lime juice, not a number of ginger beer, and not a number of lime wedge. Now, this isn't ideal, but it gets the message across that, you know, it wants you to use ginger beer and lime wedge, but it didn't know the amount that you should use. And realistically, if you're making one of these cocktails, you don't actually use an exact amount of either of those, other than you use 1 lime wedge, or maybe 2 if you're feeling like it. And instead, for like something like ginger beer or like, you know, ginger ale, you just top up your glass with it. You're not measuring how much you're using. So it gave a completely reasonable recipe. And, you know, my favorite cocktail is a lemon sour. So, lemon wedge, superfine sugar. It seems like this is a data issue. 3/4 ounce of lemon flavored vodka. Okay. 3/4 ounce of fresh lemon juice. 1/4 ounce of simple syrup. And a lemon wedge of fresh lemon juice. So, it's just a bunch of lemons and simple syrup and vodka. But that's pretty close. A lemonade, it's saying Mandarin Napoleon liqueur, peach schnapps, lemon juice, and simple syrup. I've never heard of Mandarin Napoleon liqueur. Let's look that up. Maybe that's something reasonable. Okay, it's Mandarin orange peel like liqueur. I guess that would be decent in a lemon drink. That's certainly a novel idea. I've never heard of this before. I mean, this is obviously something that exists and it exists in current cocktails, but who knows? You know, maybe this is a decent drink. Let's see if this model just learned to copy an exact recipe, or if it actually decided to come up with a new way of using this ingredient. So let's pull up our training set. So it had a Mandarin Sour, which is this Mandarin liqueur and lemon juice. And so whenever we asked for a lemonade, it was saying use this Mandarin liqueur, peach schnapps, and lemon juice and simple syrup. This sounds like a decent drink. Unfortunately, I don't have this Mandarin Napoleon liqueur, but this sounds like something I would drink. I have the rest of this stuff. How about does it know a Japanese drink? No. In fact, is this just the blank? Okay, so the blank still goes to light rum triple sec. I'm not sure why that is. That's kind of consistent that it does that. We can check our original things. Rum Coke is just doing rum and like Campari, so it's not doing Coke yet. What about tequila? Does it know what this is? Tequila, vermouth, and Angostura bitters. So no. Or is it tequila Beck? Lime wedge, 2 ounces of lime wedge coarse salt, 1.5 ounce of Campari, and then an extra lime wedge. So you're just getting a lot of salty lime and some Campari. Not a pleasant drink. What does it think goes in a margarita? Blanco tequila, Cointreau, fresh lemon juice. That's exactly the recipe for a margarita. Or it's a valid recipe of a margarita. So yeah, it seems like it's good. Let's see if we can see if it knows to modify some drinks if we ask for other ingredients, like a lemon margarita. So it's doing lemon wedge, citrus flavored vodka, Manzanilla sherry. Yeah, so it's unfortunately we're not really seeing it take an existing recipe and add a new ingredient to it. That would be an interesting thing to try to shoot for. Oh wait, hang on. So lemon margarita didn't work, but margarita lemon did. It took the same ingredients that went in a margarita, which was this tequila and simple syrup, and like lime juice, and what else was in a margarita? It got rid of the Cointreau, but it did add in lemons. So it is learning a little bit about what makes a drink and adding in modifiers. What if we do like an orange margarita? Yeah, absolutely. Actually, this is again a valid like margarita that would be more orange. It's still using like triple sec, but triple sec is already an orange liqueur. What about strawberry? Black cherry flavored vodka. Strawberries. Lemon or lime juice. Fresh lime juice. So it still pulled some of the margarita key ingredients, but it didn't get everything. Yeah, so like let's see, Moscow Mule, it got right. What if we add strawberry to a Moscow Mule? Yeah, no, it's only barely passable on drinks that absolutely exist. Like a Moscow Mule, that's a very popular drink. A margarita, that's a very popular drink. Once you start adding extra ingredients to those drinks, it's really hit or miss. So yeah, like we can try adding like lemon to the end of drinks, and here we added strawberry. Let's see about lemon. Bourbon whiskey, elderflower liqueur, lemon juice, and simple syrup. This is not a Moscow Mule, but I mean it is a drink. I can't imagine it's good. Those are elderflower and bourbon. I don't think are typical things that you mix together, because bourbon is like a really powerful alcohol that like macho men drink, and then elderflower liqueur that goes in fancy fruity cocktails. So who knows? It's a mix of both worlds there, definitely, and it's called a Moscow Mule lemon according to this AI. Ginger lemonade also doesn't have any ginger in it. Yeah, so I think we have a good place to continue on more in the future. I'm gonna go ahead and push what we have right now to the current GitHub, and we'll see what to do from there. I need to add something to our ignore. Otherwise, it's going to add all of our data. We don't want to add all of our data. We want to ignore the data. First pass model. Oh, I'm logged in with a different account. Let's just go ahead and do it from the command line. I'm using a different user than my GitHub. I was using my personal GitHub, and I need to not do that. Makes sense. Cocktail creator. I need User online, command line. There we go. Logged out of my old account, or my personal account, and logged into the correct account. So, first pass model is complete and added onto there. Let's see. Is it worth doing another thing before I sign off? I guess probably not. So I think here's a good stopping point for today. My plan over the next several months is to do streaming like Tuesdays and Thursdays my time. Like today is Thursday, my time at like 10:40 p.m. right now. Same idea. I think my schedule is on my Twitch profile. I'll probably be alternating projects just so that things are kind of interesting and different things. So I think on Tuesdays for now I'm going to be working on the Pokemon Nuzlocke AI, and Thursdays I'll be working on the Cocktail Creator AI. Today was a really productive day, and I also had a lot of technical issues at the beginning. But leave a follow if you want to. Otherwise, I'm going to go ahead and sign off. Thanks for watching.